In the winter of 1943, deep in the Union Pacific's engineering offices in Omaha, Nebraska, a classified report landed on the desk of Chief Mechanical Engineer Otto Jabelmann. The document contained intelligence photographs and technical specifications that would fundamentally alter the design of what would become America's most famous locomotive. The source? A Soviet behemoth operating 8,000 miles away in the frozen wastes of Siberia, a machine so audacious in its engineering that it made the proud American designers question everything they thought they knew about steam locomotive design. The locomotive in question was the Soviet P-38 class, and it was doing something that American engineers had declared impossible. To understand why this Soviet machine terrified Union Pacific's best minds, you need to understand the context of 1943. The United States had just begun deploying the Big Boy, officially designated the 4000 class, a locomotive that would cement itself in public consciousness as the largest, most powerful steam engine ever built. With a 4884 wheel arrangement, 132 feet of American steel, and a weight exceeding 1.2 million pounds, the Big Boy represented the absolute pinnacle of what American industrial might could achieve, or so everyone thought. The engineers at Union Pacific had spent years perfecting the Big Boy's design. They'd pushed articulated locomotive technology to theoretical limits. The math was bulletproof. The metallurgy was cutting edge. The Big Boy could haul 3,600 tons over Wyoming's Sherman Hill at 70 miles per hour, a feat that seemed to defy physics. American railroad journals praised it as the ultimate expression of steam power. Even German and British engineers sent congratulatory cables acknowledging American supremacy in heavy locomotive design. But the classified intelligence report told a different story. The Soviet P-38, working the brutal Trans-Siberian Railway route between Ulan-Ude and Krasnoyarsk, was hauling 4,200 tons, not over gentle grades, but through mountain passes where temperatures plunged to minus 40 degrees Fahrenheit. The locomotive achieved this while consuming 15% less coal than comparable American designs. The specifications seemed impossible. Jabelmann read them 3 times before calling an emergency meeting with his senior design team. The problem wasn't that the Soviets had built something bigger. They hadn't. The P-38 was actually slightly shorter than the Big Boy and weighed marginally less. The problem was efficiency, a word that made American locomotive designers deeply uncomfortable in 1943. American steam locomotive design had always prioritized raw power over fuel economy. Coal was cheap. American railroads had abundant supplies. Why optimize for efficiency when you could simply burn more fuel? The philosophy had served the industry well for decades. But the Soviet approach revealed a fundamental flaw in this thinking. You could have both power and efficiency if you were willing to rethink basic assumptions about steam expansion and heat recovery. The P-38's secret lay in its boiler design and steam distribution system. Soviet engineers had implemented a compound expansion system that American designers had tested and abandoned in the 1920s. The American experiments had failed due to excessive mechanical complexity and maintenance nightmares. But the Soviets had persisted, refining the technology over 15 years of brutal field testing in conditions that would destroy lesser machines. The compound system worked by expanding steam twice. High-pressure steam entered the first set of cylinders, performed work, then, instead of exhausting to atmosphere, transferred to larger, low-pressure cylinders, for a second expansion cycle. This extracted significantly more energy from each pound of steam. The thermodynamic advantages were undeniable. American engineers knew this. But they'd convinced themselves the mechanical complications weren't worth the fuel savings. The Soviets proved them wrong. What made the P-38 particularly galling for American designers was its brutal simplicity in other areas. While Union Pacific engineers had obsessed over precision manufacturing tolerances and complex valve gear systems, Soviet engineers built their locomotives to withstand abuse. Clearances were looser, parts were heavier and more robust. Maintenance procedures assumed harsh conditions and limited repair facilities. The P-38 could operate for weeks with maintenance that would sideline an American locomotive within days. This wasn't sophistication, it was a completely different design philosophy. Yabelman faced a dilemma. The big boy was already in production. 25 units were being manufactured. Retooling for a compound expansion system would cost millions and delay deployment by years. But the implications of the Soviet design extended beyond one locomotive class. If the P-38's efficiency advantages were real, and the intelligence reports suggested they were, then every American articulated locomotive design was fundamentally compromised. The response was swift and quiet. Union Pacific couldn't redesign the big boy, but they could modify future production runs and create experimental variants. In late 1943, authorization was given to develop what internal documents called the Compound Development Program, a classified project to test Soviet-style expansion systems on American locomotives. 3 modified 4-8 8-4 units were built between 1944 and 1945. These machines never received the Big Boy designation. They were numbered in the 4020 series and operated primarily on test routes in Nevada and Utah, away from public scrutiny. The goal was simple. Could American manufacturing adapt Soviet thermal efficiency without sacrificing American reliability? The results were mixed and revealing. The modified locomotives achieved fuel consumption reductions of 12 to 14% compared to standard big boys, slightly less than Soviet figures claimed, but still substantial. At 1943 coal prices, this represented annual savings of over $50,000 per locomotive. Multiply that across a fleet of hundreds of articulated engines, and the economics became impossible to ignore. But the mechanical challenges were real. The compound system added complexity that American maintenance crews struggled with. Parts failure rates increased. The locomotives spent more time in shops. Repair costs partially offset fuel savings. Most critically, the compound system required a different operating technique. Engineers trained on simple, expansion locomotives had to learn new skills: when to admit steam to which a cylinder sets, how to manage pressure differentials, how to prevent thermal shock during startup. The American railroad industry, conservative by nature, resisted these changes. Union Pacific quietly shelved the Compound Development Program in 1947. The 3 experimental locomotives were eventually converted back to simple expansion or scrapped. Official histories of the Big Boy make no mention of the Soviet influence or the compound experiments, but the P-38's impact extended beyond these specific machines. The intelligence that reached Union Pacific in 1943 sparked a broader reconsideration of American steam locomotive design philosophy. Engineers began asking uncomfortable questions. Had American railroads prioritized the wrong metrics? Was raw power less important than thermal efficiency? Could lessons from Soviet design improve American locomotives without wholesale redesigns? These questions led to subtle but significant changes in late-generation steam locomotive design. Boiler insulation improved. Steam passages were redesigned to minimize heat loss. Valve gear systems became more efficient. These weren't revolutionary changes. American manufacturers couldn't admit they were learning from Soviet engineering during the Cold War's early years. But the improvements were real and measurable. The irony is that the P-38 itself represented Soviet adaptation of American ideas. The basic articulated locomotive concept had been developed by American engineer Anatoly Mallet in the early 1900s. American manufacturers had built thousands of articulated engines, but Soviet engineers had taken the American concept, stripped away assumptions based on cheap fuel and abundant maintenance, and optimized for different constraints: extreme cold, limited coal supplies, minimal repair infrastructure. The P-38 succeeded because Soviet requirements forced innovation. American locomotives could be complex because American railroads could support that complexity. Soviet locomotives had to be efficient because Soviet conditions demanded it. The result was a machine that challenged American engineering supremacy at precisely the moment when American confidence was at its peak. The classified intelligence reports that landed on Jobelmann's desk in 1943 contained another detail that Union Pacific found particularly disturbing. The Soviets were building these machines in enormous quantities. Production figures suggested over 800 P-38 class locomotives would be manufactured between 1941 and 1950. For comparison, only 25 big boys were ever built. This production scale mattered because it indicated Soviet confidence in the design. American articulated locomotives were custom machines, built in small batches for specific routes. The P-38 was standardized mass production, a fundamentally different approach that suggested long-term strategic thinking rather than short-term problem-solving. The post-war period saw American engineers quietly studying every piece of Soviet locomotive intelligence they could obtain. Technical journals from Eastern Europe were translated and circulated among designers. Escaped engineers were debriefed. Occasionally, through neutral countries, detailed specifications were obtained. This information never entered public discourse, but it influenced dozens of design decisions throughout the late steam era. By the 1950s, as dieselization began replacing steam power, the lessons of the P-38 became less relevant. Diesel-electric locomotives operated on completely different principles. The thermal efficiency advantages of compound steam expansion meant nothing in a diesel-powered world. The brief window where Soviet steam locomotive design could influence American engineering closed as rapidly as it had opened. Today, the P-38's influence on American locomotive design remains largely unknown. Railroad historians focus on the big boy's impressive specifications and iconic status. Museum displays celebrate American engineering triumph. Few mention that in 1943, for a brief moment, Soviet engineers had achieved something that made American designers fundamentally reconsider their approach. The big boy became legend precisely because it embodied American values: massive, powerful, impressive, built without compromise. The P-38 represented different values: efficient, practical, designed for harsh reality rather than impressive specifications. Both machines were engineering achievements. Both reflected the cultures and constraints that produced them, but only one forced the other's engineers to redesign everything they thought they knew. The story of the P-38's influence on American locomotive design reveals something uncomfortable about engineering progress. The best solution isn't always the most celebrated. Innovation often comes from constraint rather than abundance, and sometimes the machines that change history aren't the ones that end up in museums. They're the ones that force their competitors to question fundamental assumptions. The Union Pacific never publicly acknowledged Soviet influence on their locomotive designs. The compound development program remained classified until the 1990s. The 3 experimental locomotives were scrapped without fanfare. Official histories continued celebrating the big boy as purely American innovation. But in engineering offices, in technical discussions away from public view, the lesson was clear. The Soviets had done something remarkable. They'd built a machine that the Americans, with all their industrial might and engineering expertise, could not simply dismiss. In the end, history remembers the big boy. Children know its name. Museums display it. Photographers chase it. But the engineers who designed it, the men who understood the technical challenges and theoretical limits, they remembered something else. The winter of 1943, when a classified report from Siberia forced them to admit that somewhere in the frozen wastes 8,000 miles away, someone had figured out how to do it better. That knowledge changed everything. Not in obvious ways, not in ways the public would notice, but in the quiet, methodical world of engineering design, where every specification matters and every efficiency gain compounds over millions of miles. The P-38 cast a long shadow. The Soviet monster that made Big Boy's engineers redesign everything wasn't just a locomotive. It was a challenge to American technical supremacy at the moment when that supremacy seemed most secure. And in meeting that challenge, however quietly, however reluctantly, American engineers proved that good design recognizes excellence regardless of where it originates, even if acknowledging it publicly remained impossible.